You probably won't believe it, but with just these 10 electronic components you can build a guitar overdrive, and in today's video I will show you how to do it step by step and without any soldering. So to do this you will need a 100 kΩ logarithmic potentiometer, one BC547 transistor, one 100 microfarads electrolytic capacitor, one Zener diode C2V7, so rated for 2.7 volts, one BAT43 diode, two resistors, one 100 kΩ and one 5.6 kΩ, and finally three capacitors, 1 nanofarad, 10 nanofarads and 100 nanofarads. Today, using all these components, we're going to build a fully functional circuit on a breadboard, no soldering required. You will also need some jacks to connect to your guitar and output to amp, and of course DC power jack and some jumper wires specifically for breadboards to connect everything. If you don't know how a breadboard works, I already made a video about that. I will drop it in the corner so you can click it. I also put all the links in the description, including links to other relevant stuff. Also, a quick reminder, on my website you can order a DIY distortion kit, which includes exactly the same breadboard I'm using in this video. If you want to learn more about this DIY kit, be sure to check links in the description. Okay, so I prepared the full list of the components for you. You can screenshot it right now, or you can pause the video and make some notes. I'm pretty sure you will find easily everything online. Okay, so let's get to work. I've printed the schematic for you. Feel free to take another screenshot and save it. I also printed it smaller so it fits better in the frame. That way we can always reference it as I show you step by step how I connect everything and how it matches the schematic. First, we're going to mount the jack on the breadboard. I'm using versions designed for PCB mounting, which have pins instead of soldering lugs. And a quick note, you should be aware of connecting everything to the correct pins, to this one on this side, because when you will plug in the cable, check this out, it will break the connection. So actually if you connect everything on this side instead of this, it will not work. Okay, so let's mount another jack, and remember that on this side we will have the correct connection pins on the bottom, not on the top. Next, let's connect the power jack. As you can see, I soldered some wires here. The larger pin is negative and the smaller one is positive. Remember, most of guitar effects use power supplies with negative center pins and positive outer sleeves. In this case it doesn't matter much because you can just rotate jack when connecting it to the breadboard, still it's important to pay attention. The circuit will also have a diode, the BAT43, to protect against reverse polarity. If you plug in the power the wrong way, the circuit won't work, but it also won't get damaged. So this is it, BAT43. The black band side is negative. So you need to connect positive side to the positive side of the jack and the red rail with negative side. This is how it looks. Aside from the diode shown here in the schematic, we also have a capacitor to help filter the power supply. You can either trim its legs or bend them like I did. Just make sure the gray stripe on the capacitor is connected to the negative rail, the blue line, and the red line goes to the diode. The diode's positive side connects to the power jack. Now we will install the potentiometers so we can start positioning the larger components in a way that's comfortable to work with. After that, we will connect some jumper wires. Let's start with plugging the ground connections on our jacks. Let's start with the input jack, so this is the ground pin. You should connect it here and to the negative rail on the top. Same with another jack. This is the ground pin and you need to connect it here and on a negative rail on the top, just like this. We'll use the rest of the jumper wires later. Now let's focus on the other components. So let's go with this capacitor. It's 10 nanofarads, so I need to find 103 mark. But of course other manufacturers can use different marks like just 10N or 0.01. According to the schematic, one leg needs to go to the signal pin and we'll connect the second one later. So this is how it looks right now. Next, let's install the transistor. Mine is a BC547B. You can try another type, but be sure to check the pinout. In this one, the emitter is the right leg, base is the middle, and the collector is the left. On the schematic, this is the emitter, this is the base, and this is the collector. Other transistors might have legs in a different order, so be careful. I spread the transistor's legs a bit so that there's one pin of space between each leg on the breadboard. That gives us more room for connecting other components. Try not to place it at the edge of the breadboard. You'll want a room to connect things on both sides. So this is how it looks right now. Remember, you can always pause the video and make everything in your time. So now I'm connecting a jumper wire from the emitter, the right leg, to the blue rail, so our ground. So let's go with another part. Let's focus on this 100K resistor. One leg goes to the positive rail and the other goes to the collector, the left leg of the transistor. So this is how it looks right now. Take a closer look. If you need, pause it and think if you did everything in a correct way. So now let's take a look what should be connected to the base, so the middle pin of our transistor. As you see, there's a 1 nanofarad capacitor, so let's connect it right now on the top. One leg to the base and one to the ground, so the blue rail. This is how it looks right now. So let's focus on the R1 resistor, so 5.6 kilo ohms. It should be connected to the C1 capacitor and to the base. We already have C1 on our breadboard, so just connect it to the second leg of the C1 and to the base, just like this. Okay, so we have all those components connected. Let's focus on a Zener diode. This is how it looks on the schematics, and it should be connected with the black band side to the collector, so the left pin on a BC547. Positive side, so the second leg should be connected to the middle pin of our transistor, so the base. This is how it looks. Okay, so basically just one component left, and it's 100 nanofarads capacitor. And we're connecting this capacitor with one leg to the collector and the other to the third leg of our potentiometer. And the third pin is on the right side of the potentiometer, just like this. Okay, so every component is on a breadboard, but we need to connect those two last jumper wires. We will connect the ground to the first pin of our potentiometer, so it's the left one. And the second jumper wire will be connected to the output, so this pin on our jack. So this pin and the middle pin on the potentiometer, just like this. And that's it. Basically, we're done. Let me know if you also like a tutorial on how to design a PCB where everything can be soldered permanently. Alright, the circuit is assembled, time to test it in action. I prepared some demos for you, so let me know in the comments how do you like it. Cheers, have fun!